Now we are going to see a section formula, that is first internal division. If a point Px, y divides the line joining the points A x1 y1 and B x2 y2 in the ratio m is to n internally, then x is equal to mx2 plus n x1 by m plus n and y is equal to m y2 plus n y1 by m plus n, right? P is any point on the straight line AB, segment AB. Then the coordinate of P is given by mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. So to find the coordinate of the point which divides the line joining two given points in the given ratio. The point Px, y divides the line joining the points A x1 y1 and B x2 y2 in the ratio ms to n internally, then x is equal to mx2 plus nx1 by m plus n, y is equal to my2 plus ny1 by m plus n. Let ox and oy be the x-axis and y-axis respectively. So we draw oy, ox axis, right? Ax1 and bx2 any 2 points. So we fix the points, join AB. Given P divides the line joining A and B in the ratio m is to n. So we mark P, so AP m and PB n, right? So AP equal to m, BP equal to n. Clearly the point P lies on AB, right? So draw AL perpendicular to YX, right? BM perpendicular to YX, PN perpendicular to YX. Clearly the lines AL, BM and PN are parallel, correct? Now AL, which is equal to the length, that is y coordinate of A, that is y1, right? And BM is the y coordinate of B, the point B, that is y2, and PN is the y coordinate of the point P, that is y, right? Now OL, x coordinate of A, that is x1, OM, that is x coordinate of point B, that is x2, and ON, that is the x coordinate of the point P, that is x. Draw PR perpendicular to AL. Now we are drawing a line from the point P which is perpendicular to AL, right? Now BS perpendicular to PN, right? We are going to draw a line from the point B to PN, perpendicular line, right? Right. So we'll take that. Now RL, which is equal to the length RL, which is equal to PN. Both are equal, that is equal to y, right? SN, which is equal to BM, that is equal to y2. Now PR, the length PR, which is equal to LN, right? LN can be written as ON minus OL, that is x minus x1, that is 1. And BS, everything is marked in the diagram, so you can easily find out, right? Then BS is equal to NM, which is equal to OM minus ON, that is x2 minus x, that is equation number 2. PS, which is equal to PN minus SN, that is y minus y2, that is equation number 3. Then AR, which is equal to AL minus RL, that is equal to y1 minus y, that is equation number 4. Consider the right angle triangle APR and triangle BPS. Both are similar, that is AAA similarity. Three angles are similar, right? Because right angle triangle R and S 90 degree, right? And AB is transversal, cuts the line PN and BM. So angle PAR, which is equal to angle BPS, corresponding angles, and angle APR, which is equal to angle BPS, third angle, right? Since the corresponding sides of similar triangles are proportional, so we are using that idea. So AR in the first triangle divided by PS in the second triangle, which is equal to PR by a second triangle BS, that is equal to AP first triangle and BP second triangle. We know the values. Since we are taking first and third equality, right? AR by PS, which is equal to AP by PP. AR we know y1 minus y, and PS is y minus y2. AP is m and BP is n, which is equal to m by n, by using 3 and 4. So cross multiplying n into y1 minus y, which is equal to m into y minus y2, splitting. So we are multiplying with the n, so n y1 minus n y, which is equal to, now right hand side multiplying with the m y minus m y2. So now we are grouping y on one side and y1 y2 on the other side. So n y1 minus m y2 becomes plus m y2, it is coming to the left hand side. Similarly, minus ny coming to the right hand side, it will become plus ny. So my plus ny. In the left hand side, y is common, so m plus n into y, right? M plus n into y, which is equal to my2 plus ny1. Therefore, y, which is equal to my2 plus ny1 by m plus n, which is the y coordinate of the point P, correct? Similarly, now consider the next two equalities. PR by BS, which is equal to AP by BP. So PR we know x minus x1, BS which is equal to x2 minus x, which is equal to m by n. Cross multiplying. So we are using 1 and 2. Cross multiplying n x minus x1, which is equal to m x2 minus x. So splitting nx minus nx1, which is equal to m x2 minus mx. So nx plus mx, which is equal to mx2 plus nx1, right? So x is common, take it outside, m plus n into x, which is equal to mx2 plus nx1. Therefore x is equal to mx2 plus nx1 by m plus n, which is the x coordinate of the point P. Therefore the coordinates of P x comma y, which is equal to P of mx2 plus nx1 by m plus n, my2 plus n y1 by m plus n, right? Thanks.